Algebra Half Lesson 20 is called Multiples and Least Common Multiples, or as we like to call it, LCM. This lesson is basically the opposite pair to our lesson on greatest common factors. I'm just paging back to see which one that was. Doesn't feel like that long ago, but maybe it was further than I remember. Lesson 13. So we've been 7 lessons removed from page 48 when we learned about factors and greatest common factors. Now we're on page 70 talking multiples, least common multiples. And in so many ways, it's just the opposite lesson than that one. What is a multiple? One way to define it is relative to what it's opposite to. Multiples are like the opposites of factors. For example, 3 times 4 is 12. What are the factors? 3 and 4. Numbers that when multiplied together equal a product. What is the multiple? It's the product. 12 is a multiple of 3 and 4. And today we want to not only talk about those, but talk about how can we find the least common multiple of two numbers. The numbers 2, 4, this is page 70. Numbers 2, 4, 6, 8, 10, 12, and 14 are the multiples of 2 because they can be composed by multiplying 2 and a counting number. So when you count by 2s, every single number you pick is a multiple of 2. When you count by 3s, 3, 6, 9, 12, you're counting the multiples of 3, and so on and so forth. Basically, it's the numbers when multiplied by a counting number. Example 20.1. Take a peek on page 71. It says the number 8 is a multiple of which numbers? We can compose 8 by multiplying 2 and 4, right? 8 is a multiple or product of 2 and 4 multiplied together. We could also say that factors 1 and 8 are factors of the multiple 8. So it's just another way of asking for the factors of 8. 1, 8, 2, 4, all are factors. Or, as this question asked, numbers that have the multiple of 8, I guess is how you could say it. So it's just different ways of asking for similar things. Keep it straight that multiple is the number you get when you multiply factors. Now, least common multiple can be found a certain way like we did with GCF, but now with LCMs. For big numbers where maybe it's not so easy just to list all the factors and then pick the ones that they have in common. Instead, we've got tricks to do this, and usually they involve, right, factor trees. So to find the LCM of big numbers like 24, 55, and let's put 80 over here. Okay, we factor tree them first. 24 is going to have the factors 2, 2, 2, and 3 if we just fast forward. So we list the factors of 24 as a list of prime factors. 2 times 2 times 2 times 3. This should be an equal sign. Okay, then what are the factors of 55? We factor tree it. And we get, let's do this one together, 5 and 11, right? That was easy. Those are the only factors besides 55 in itself. And those numbers aren't prime, so we won't use them in our list of prime factors. Finally, 80 is one we could do together. Which two do you want to pick? Why don't we just pick 10 and 8, 2 and 5, 2 and 4. And am I done? Nope, quite. 2 and 2 to get 4. So I got a lot of 2's on this one. Make sure you list all of them. Be very complete when you're doing your lists. 2, 2, 2, another 2, and a 5. You can always check your list of prime factors, right? Calculator out this and see if you get 80. All right, now I've got my lists of Prime factors, what do I do with them? To compute the LCM. Maybe you want to write down in your notes line paper, page 71 is how to do LCM, so you keep it straight, the process from GCF. Because so far it's the same. But we're looking for the least common multiple, so a number that will be bigger than all these numbers. It's not a factor that goes into all these numbers. It's a number that all these numbers go into themselves. It is a multiple of all these numbers, but the lowest one that we need. And obviously that's a number that will be helpful for a lot of operations in the future. Take a look at number 1 on page 71, down by where it says least common multiple, and it's got the rules. First, you write each number as a product of prime numbers, which we've done. What's number 2? Compute by using each factor as a factor in the LCM the greatest number of times it's a factor in any given number. Sounds complicated. It's super easy. You just have to keep it straight. And remember, page 71 LCM, we look for the 2's. When 2 is a factor of any of these numbers, what is the most it's ever used? 2 times 2 times 2 times 2, right? 4 times. In our final answer, we will use it 4 times. We will not use it another 3. Those will get left out because we're just looking for common and we need it to be least. How many times is 5 used the most in any given number? It's a tie at 1. Let's use this one. Times 5 to the first, if you want to show that. What's the next? Ooh, we skipped 3. Let's include our 3. Should have listed that least to greatest. And there's an 11. This is going to be a pretty big number, and that's okay because it is a multiple. It's a opposite of a factor. When multiplied all together, 2 times itself 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 5 times 3 times 11. It's going to be a huge number, and look at it, 2,640 if you type that into your calculator, which would be fine. You just need to show this, and this in your work. This you can do in your calculator, and the final answer for multiples should always be much bigger than all 3. Whereas in GCF, we were looking for a number that goes into all of them, and it's the biggest of all those. So it's the complete opposite. Forget everything you knew about GCF in this lesson. Do practice A, where you find all multiples of 7 that are less than 56, aka practice A, count by 7s until you stop at the one before 56. It's preschool math. You can do this. Just think about what it's asking and check out example 20.1 if you need another reminder of how we did that. And then I'd like you to do both C and D. Why? Because you're going to do so many of these. You're going to need to do them in other types of problems. You need to get this down like a science and don't get it mixed up from GCF. This is LCM. Do your very, very best. Don't get it mixed. Good luck.